Dear students, good morning to everyone. Today we are going to discuss about introduction of correlation. First, we discuss correlation, the measurement of relationship. What is the relationship of measurement in correlation? First one, aims at discovering the linear relationship between among two or more variables. Example, study habits, class attendance, academic background and performance in examinations. The second one, knowledge of strength of relationship is used in the prediction. Third one, where there are two variables, simple linear correlation is used, but for more than two variables, multiple linear correlation is used. Fourth one, zero order partial and part correction should be distinguished. Cations. That is, first one is correlation does not imply cations. Second one, check for linearity. The last one, the correlation coefficient to use depends on the scale measurement. Next one, uses in research. Next, correlation. Correlation coefficients are used to interrupt the nature of the linear relationship. These coefficients range from -1 to +1, that is called positive to negative. Scatter plots. A scatter plots or scatter diagrams shows the nature of the relationship between any two variables. To obtain a scatter plot, marks are made on a graph representing the intersection of the two variables. Scatter plots could either be linear or curvilinear. This is the diagram of linear relationship. Curvilinear relationship. Linear relationship is a straight line. This is the linear relationship. This is the curvilinear relationship. Next one, assumptions. The variables random. Neither the values of x nor y are predetermined. The relationship between the variable is linear. The probability distribution of x is given. A fixed y is normal. That is, the sample is drawn from a joint normal distribution. The standard deviation of x given each value of y is assumed to be the same, just as the standard deviation of y is given each value of x is the same. Assumes the following scores in two tests. Y distribution. Next, nature of the linear relationship. The linear relationship described by directing and degree. The first one is positive. High values go with the high values and low values go with low values. Negative. High values go with the low and low values go with the high. That means positive value is the same growth or the same increase or same decrease, but negative is high to low and low to high. This is the perfect positive, perfect negative, moderate correlation, zero correlation, high positive correlation, low correlation. Figures in diagrams. Commonly used types. Pearson's product moment correlation coefficient. This is applicable when both variables are continuous in nature. It uses interval and ratio scale data. For example, the relationship between test scores and age of students. Second one is the Spearman's rank correlation. And these are 5 types of correlation. The first one is Pearson's. Second one is Spearman's. Third one is Kendall-Staff. Fourth one is Kendall-Stoss. And fifth one is pi coefficient. Commonly used types. Next, causation and correlation. The presence of a correlation between two variables does not necessarily mean that there exists a causal relationship between the two variables. A very strong or high relationship between two variables does not imply that one caused the other. No cause and effect relationship is determined purely by correlation coefficients. Next formula. The product moment correlation coefficient. Covariance of xy by xs sy is equal to summation of x minus x bar into y minus y bar by n into xs into sy. That is a small n into summation xy minus summation x into summation y whole divided by square root of n into summation x squared minus summation x the whole squared into n into summation y squared minus summation y the whole squared. This is the product moment correlation coefficient. Next one, the Spearman's rank order. Rho is equal to 1 minus 6 into summation d squared by n into n squared minus 1. The phi coefficient, the normal scale variables, pi is equal to square root of psi squared by n. The coefficient C, the normal scale variable C is equal to square root of x squared by n plus x squared. These are the formula. Thank you.